Hello my friends, welcome to Inside Electronic channel. This is Uncle Misha with you today, and we have Fluke 8600 a digital multimeter, and it definitely not doing well. I'll show you what's going on with it. I actually had repaired this one already in video like about 6 or 7 years ago. Look at this post right here. It was an issue with cracked board, and I did some repairs and cleaned up switches, and it was okay. Now it's showing some weird ass problems. Let me show you what's going on. Let me find a power for it. Oh, it's not easy then to show you. Okay, I'll try something like that. Power it up. Jeez, I said power it up. Oh, it's really hard to see, but take a look what's going on with this guy. So this is DC mode, right? Range is like, look at this, it's tripping like crazy. Let's do AC. It's like all over the shop. Let's say resistance. What the heck is this supposed to be? There's something wrong with this guy. So now we have to open it up and take a look what's up. Maybe we can clearly see some kind of failure, or maybe that's we have some kind of even worse issue, because this is actually a nice unit. I was using it for some time, and then I stopped using it for a long time because I got this Fluke, right, and it was the portable multimeter, but this one's still pretty decent. Also, as you see, the display is pretty dim, so we're gonna take a look at that as well. So for that we have to unscrew it, and I think it's unscrewing pretty simply. I think somehow this is supposed to be detaching. Anyways, so let's start disassembling this Fluke and let's focus. So let's start disassembling this vintage multimeter, and I do not remember where are... It looks like it's just one screw right here. Wow. And this particular one was a like data output option, not battery option. I would like to have a battery option. Maybe I will convert this one into battery option. So hence this like slot out here, because it was a board. Yeah. Well, this assembling procedure is very simple. Ta-da! Okay, so here is the board itself. It doesn't look like I see any visible damage. So what could have happened here? First of all, I have to double check capacitors, because there is a possibility that capacitors are gonski or getting there. Okay, those are LED displays, so they're not supposed to be affected by the... They are not VFL displays, so they're not supposed to fade with time, so they are supposed to be fine. Okay, no, I think it's fine. Okay, so we have several capacitors, we have to double check them all, but I think the very first thing, because I go into capacitors, I have to check all these switches. So for that I have to probably unscrew a little bit more. Oh, here we are. So here's my repair, by the way. So I repaired this. So yeah, that was broken. It looks like this thing had the tumble. I think we have... Can we? Well, probably we cannot. Okay, so I thought I have to remove the front panel, but I think I can try to clean up switches just spraying some contact cleaner right here. That's I'm gonna do first. Then I'm gonna take a look at those capacitors, but seems to be capacitors here are pretty decent, and none of them leaked. For example, this 47 47 50 volt cap, there's not that many electrolytic capacitors which would have gone bye-bye. What's cool about it, all those cheapies, they are socket mounted, so technically I can replace them. So this particular ASIC. I think this is ASIC. Is socket mounted as well. It's like 48 pin Joby or something to this extent. It's pretty big. We have several relays, we have several boards. Boards are, I think they are, so they are not soldered. I think those boards, they are socketed. Are they? Or they are soldered? It's really hard to tell. It's really hard. No, they are socketed. So yeah, so technically I can just, I can just pull this board out. For the purpose of checking, not necessarily I need to. I just want to see if there's any damage to components. Even resistors here, it's kind of funny. They are, you see those resistors? They actually socketed. I don't know why. What are those? It's interesting. But this is another possibility of failure and oxidation. Those socket pins, they can start oxidizing and they make a bad contact. There are a few tantalum capacitors here, like these guys, so hope they are okay. I don't think they are leaking. And 10 microfarad 25 volt. This is candidates to be double check. So we're gonna pull out my ESR meter and check all those 3 tantalum capacitors. There's more tantalums here, but they are in a good shape. Visually they are in a good shape, but still have to check them to be 100% sure. So we're gonna do that. So let me pull my, you know what, before I actually start fiddling with capacitors, I'm gonna clean up switches and test it. So for this purpose I have my favorite contact cleaner and I'm gonna just spray it. I'm gonna use my gloves for protection because your eyes is probably one of the precious part of your body. I'll just spray each individual like this, and then just work them through. Ranges, everything has to be, oops. Maybe I shouldn't be that aggressive, maybe. It also feels like I should have not unscrew. Gonna put this back on. Okay, one of the switches I can't even reach, so I have to remove this board, looks like, which is sucks, but I have no choice. That will be hard to reach. There is no other way. Wow. Okay, so board number 1 with those funky resistors in a microchip slot, which is super weird, but doesn't say what kind of board is this. Ohms conversion assembly. It says ohms conversion assembly. Right, go right here. Then what is this? This doesn't say what it is. This is input divider. Okay, input divider. Cool. And this is probably AC circuit. Doesn't say what it is. Well, it's probably hardest to remove board. Maybe not. It has one wire. And what kind of board is this? Doesn't say. Really, I don't see it. Okay, not gonna play with it, but at least we can spray. And now we have to work them. Work those contacts well. So now we probably have to put all this back on where it was to. It's kind of interesting that this I just double check that contact as well. Okay. Double checking that every other contact is fine, seems to be. Okay, let's just plug in this stuff back where it's supposed to be and check the operation. There's a guide pins. Okay, that seems to be good. Then it was this board. No, it was divider board. It has guide pins as well. Let's see if everything is aligned properly. Okay, it's good. And let's try this one. Make sure again everything is aligned. Looks like they are gold plated, those real pins. Okay, so we run through all our switches. So let's power it up and see where we are. Okay, have to be careful here. Still showing some weird numbers, so yeah, I would not expect it Probably was nothing to do with switches. It is an auto range, so let's switch it into like 2 range. Well, this is actually a bit better. Now it says shows 0.8, so in 20 range. So this is, I think this is okay. So let's go to resistance. I'm not sure why it shows this. Yeah, okay, there is something wrong here. Auto. Okay, the ohms mode definitely shows some weird value. DC voltage. 2. 20. Yeah. I think that's gonna be not as simple as just clean up the switches. I was hoping. Alright guys, so after we cleaned up switches, let's see if we got anywhere. So probably the easiest would be to check DC volt, but even right here in this particular range it's supposed to show 0, not +3 or whatever. Yeah, I think we have an issue. This is 0.8 and this plus is always indicating. So let's do auto. So auto range. Have a okay. Let me use this as a prop here. I want you to see, but at the same time it's awkward. Okay, it says 3.4, and this is fresh AA, so it's supposed to show 1.5 volt. What do we have? Yeah, frick, 2.7. Are you for real? 1.2. It shows 1.2, yeah. Yikes. Let's reverse. Minus. So yes, our friend here is not feeling good. Let's see resistance. I just gonna measure resistance of this. It's not even working. Look at this, it's just blinking. Actually show something. So here is my precision resistor test thingy. So 100 ohm here and 20 kilo ohm here. So let's try 100 ohm first and see what we see. Who knows what that's supposed to mean. Let's do auto. 140, 139 ohms as I understand. Okay. $23, whatever it is, kilo ohms, I guess. 200 ohms. Let's switch manually. 200 ohms mode. It's gonna be overload, of course. Let's switch 100 ohms. 140 ohms. It kind of does something. So 20. So that's the kilo ohm range. I assume. 14. 200. 23. I think we have a problem. Shit, what could be a problem? Okay, so this guy is definitely sick. So, okay. Shut it down. So contact cleaning did not help. So that means we have to pull out the service manual and check. So we will start checking this little guy with help of this little guy. Because first of all we have to check the voltage, the power supply voltage, to make sure these caps are still good. Alright guys, I have a very interesting discovery. So I let this guy to just sit there powered on for a while, and you know what happened? I think, well, I mean, I also fixed the switches. I cleaned them up very thoroughly, but also I let it sit for a while powered on, and I think it fixed itself. Well, two possibilities. Actually, when I was cleaning, the thing dried out and now it's actually worked properly. Another possibility that some of the capacitors which were so old, like for example these power ones, that they are formed after a while, because this gentleman here, it was not powered for about 5 or 6 years. So now we are in a ohms mode, so kilo ohms. This is like ohms mode, and I do have this, as I mentioned before, sort of those are the Vishay 0.005% precision resistors. All right, and let me check what we have. I'll try to prop it like this using this. Yeah, still not gonna see anything. Yeah, this sort of sucks because I don't have really nice way of videotaping it. So here I've come up with some sort of way of actually showing you this. So here's my precision resistors. Alright, so we are in ohms mode. So this is kilo ohm and this is 200 ohm range. And let's see, so this is our 100 ohm plus minus 0.0005%. So 1/5000th of a percent. That's really good resistor, really expensive. And here is our value, 102.8. Obviously it's not precise, but hey, when you switch to 2 kilo ohm mode, 20 kilo ohm mode, yeah, it's 1.0. So yeah, it's working. Okay, so let's do 200 kilo ohm and let's use 20 kilo ohm resistors, and it shows 19.99, which is not too bad. So ohms range, it's working. Okay, let's hide it back. So now let's take a DC. So this is, you know, this charged battery from Home Depot. DC range is gonna be 2. Okay, so now when we are shorted, it shows 0, which is very important. Now when we do negative and positive, we have 1.59 volt. If I take my Fluke right here, my other Fluke, it's gonna show pretty much the same, I'll already tell you. Yep, 1.59. It's obviously charged battery or not used. So here we are, and the last range, not gonna change to try currents because it doesn't have really current source. So this is AC voltage, so it's almost 0 when it's shorted. But now I do have an analog discovery. I don't know if it's gonna reach here. This analog discovery thingy, and it has waveform generator. This is channel 1 output. Let me run it. Alright, my friends, so I'm gonna supply, with help of my analog discovery using those two crocodiles, a 100 millivolt RMS or 100 millivolt AC with 2 kilohertz. Let's see how it's gonna fly. And what do we have? We have 1015. We have 100 millivolt. So this is the millivolt range actually. The millivolt range shows 100 millivolt pretty much. Well, 101 millivolt 0.5. That's pretty good for this guy. I'm not 100% sure who's precise, is analog discovery or this guy, but here we are. Let's do 20 kilohertz. So we have 20 kilohertz signal and 101.6. Let's do 50 kilohertz, and here's our 50 kilohertz signal, 101.6. 7. And the last one, let's do 100 kilohertz. So this is our 100 kilohertz. So this guy is actually rated for 100 kilohertz AC. So it can handle 100 kilohertz. So let's do 1 point overload, of course, because that's supposed to be 1 volt AC. 100 kilohertz, 1 volt AC, and you see 1.0100. It's very good precision. Again, I'm not sure like where we are because I don't have precise instrument to check. This Fluke already getting flukes at this kind of 100 kilohertz because it's not rated. So let's do 200 kilohertz. 200 kilohertz. It's still really close. I mean, you still can round this 0.998 to 1 volt AC. So I think this little guy being like, I don't know, like from 70s. What's the production date here? I don't see it. I think I saw somewhere something like 70s. Anyways, this guy being that old, and the serial number is 93058, working very well. So I think just cleaning up all those switches and letting it run for a little bit just on its own, doing nothing, actually helped it a lot. And now I have completely functional, very well, I mean, pretty precise multimeter. The only thing what I don't like, those LEDs are super dim. This is I don't like. So I'm not sure if I can fix it. Maybe bump up the voltage, maybe check capacitors again. Maybe the capacitors are leaky. Those tantalums are, they actually look good. Here are they, like they are here, those tantalums right here. They actually look good, but I didn't check any capacitors at all. Voltages, the 5 volt rail is reading 584, it's 484 instead of 5, but I checked the service manual, it says fine, that's fine range. So yeah, this is what it is. So I have to check this little LED driving board, like this guy, like here's this driver for those LEDs, and I have to check power student. But those LEDs are really dim. But nevertheless, this guy is working. LEDs is a side issue. I might take a look at that a little bit later. The only I didn't check is actually, let's do auto. Let's see what that guy, how that gonna fly. Yeah, auto works. Let me drop the voltage to 100 millivolts. So we have 100 millivolts, auto ranging. So this is really cool. I'm afraid there is nothing really to poke around here. Maybe if I have like a desire, I'm gonna go and try to use my precision resistors, and I don't really have good precision voltage source to actually calibrate. At least ohms range I would be able to calibrate, but I don't really need that precise. That how it works, it's still pretty good. So I think I'm gonna wrap up, I'm gonna pack it up, and let me see the only one thing. What date code is this thing? Okay, 74. So resonator is dated 74. Okay, I turned it the better angle. So let's see some date codes. So 84 is actually right here on that big ASIC here, whatever ASIC it is or whatever it is. 74 is on a resonator, and this resonator looks like it had better days. It's really yeah. This capacitor is from 0773. What else? What other date code we have here? So this is really hard to understand. This is RCA components, really hard to understand. This is, I'm not sure what that really means. Yeah, so some other components are unknown dates. There are some chips here. 7348. So yes, here is 7348 on this Texas Instrument, their Joby. So looks like this gentleman here from originally was built in 74, 73, because some of the components, I guess. And this guy potentially was reprogrammed in 84, whatever this 84 means. Okay, I assume this is date. But other components are from, here's some another TI Joby, and it's really hard to say, yeah, what it is. So yeah, so this guy is, okay, let me disconnect the power here. There is no dates, right, there is no dates here. Fluke 7 QA, revision C, that's all I have. Not sure if this was actually built in 80s, but they used the componentry from 70s. I'm not sure, but here we are. This is it. Yeah. At least we have serial number, and I don't see much of it on the case, unfortunately. Yeah, this is just a user manual. It says nothing about when it was manufactured, no labels, nothing like this. So here we are. Anyways, this steel unit works very well, and I will continue using it. Let me assemble it, and yeah, I'll wrap up. Alright, my friends, so we have this Fluke 8600A digital multimeter more or less operational. I didn't check, as I mentioned, the current modes, which I probably don't really care about this at the moment. So everything else seems to be working, and now I'll be using it because I need to check AC voltages at 100 and above kilohertz. This is the reason I looked into this multimeter. So I think this is sort of successful repair, kind of repair, because I didn't do much, just clean up those switches. But if you have something like that, looking at seeing my video, maybe I'll give you some ideas what may go wrong with this little guy. Also reseated some of the boards, maybe that helped as well, and that's pretty much it. Didn't do more than that. I tested it and it is working. Thank you guys for watching. See you next time. If you like my video, please like, subscribe and support the channel, and take care. Ciao.